In this example, both xn and hn are given and we are asked to find the convolution of xn and hn. There are several ways to solve this problem. You can use the graphical convolution method, or you can apply the summation formula directly. However, in this solution, we will use a more efficient approach based on two important properties of convolution. The first property states that the convolution of any signal with a unit impulse is equal to the signal itself. The second property states that the convolution of any signal with a shifted unit impulse produces the same signal shifted by the same amount. Using these properties, we can simplify the calculation significantly. First, let's express xn in terms of impulses. Xn can be written as Similarly, hn can be written as Now we compute the convolution of xn with hn. Let's first convolve xn with 2 delta of n plus 1. According to the shifting property, the signal shifts one sample to the left, and because of the coefficient 2, all amplitudes are multiplied by 2. As a result, we obtain 2 delta of n plus 1 plus 4 delta n minus 2 delta of n minus 2. Next, we convolve xn with 2 delta of n minus 1. Again, the amplitudes are multiplied by 2 and the signal shifts one sample to the right. This gives 2 delta of n minus 1 plus 4 delta of n minus 2 minus 2 delta of n minus 4. Now we add all the resulting terms together. Let's combine any impulses that occur at the same time. The impulse at n equal minus 1 appears only once, giving 2 delta of n plus 1. The impulse at n equals 0 has a coefficient of 4. At n equals 2, we have minus 2 plus 4, resulting in a coefficient of positive 2. The remaining impulses are 2 delta of n minus 1 and minus 2 delta of n minus 4. Therefore, the final output signal is 2 delta of n plus 1 plus 4 delta of n plus 2 delta of n minus 1 plus 2 delta of n minus 2 minus 2 delta of n minus 4. If we draw the output signal, the amplitudes are as at n equals minus 1, the amplitude is 2. At n equals 0, the amplitude is 4. At n equals 1, the amplitude is 2. At n equals 2, the amplitude is 2. At n equals 4, the amplitude is minus 2. This is the final convolution result. We have many more convolution examples available on the channel. If you found this explanation helpful, please like the video and subscribe for more signal and system tutorials.